Thank you. So welcome everybody. I think there's going to be a very different sort of sense of scale in relation to our last speaker that I thought was really, really interesting. It's great to kind of understand a bit more about what's happening on in the surgical world, but we're going to sort of change tack a little bit and look more at kind of city design and architecture specifically. So my lab is founded on the idea that computers and the application of computational kind of design in architecture is relatively new as compared to many other industries. And as a kind of creative sort of endeavor, there's a lot of questions about how we're going to apply them. But effectively, the kind of power of computation has a really interesting opportunity for us to kind of rethink how we design, how we kind of use different sort of data streams to sort of design better and to sort of understand our built environment better. So I'm specifically interested in how we can sort of use computers in this sort of augmented intelligence way to be able to support our own intuition and design thinking. And specifically in sort of three different areas. I'm interested in how we can use big data, things like that, for computers to kind of give us new insights onto what's happening in the built environment, which is often very vast, and it's hard as a single human to kind of really appreciate what's going on, especially at a city scale. I'm also interested in how augmented intelligence and computers can help us design better. So how do we enable computers to be kind of more creative so that they can support our design activities, which often take quite a long time? And how do we kind of collaborate better with computers? These are kind of principally where most of my research kind of lives. Today, I'm going to be interested in kind of how we apply data and specifically, how do we kind of bring in new data into the city and why is this the case? And I think what's kind of important, especially within the sort of city sort of context, is that if we sort of bring data in, we can actually help to improve things. But often if we don't have a metric for it, it's difficult to know what to improve. So we're very aware of sort of with city metrics of, how big the population is, how much money it makes per se, maybe even sort of, how long the traffic jams are. But I think there's a really interesting question about how we can maybe ask questions about how healthy a city is, how happy a city might be. And I'm very much kind of inspired by this documentary on my previous boss, if you will, Norman Foster, where there was a sort of simple question asked, sort of how much does a building weigh? Sort of how much does it work? What is the kind of physical footprint of a building? But I think there's other questions to ask that are arguably just as important, which are sort of how much does a building or an urban space kind of contribute to the citizens' happiness, or health? So I'm, as I say, sort of interested in how we can build maybe a Fitbit for a city, for kind of a neighborhood and for kind of public spaces. What would be the measures that are important there? How can we kind of use some sort of way of looking at this and sort of data from that to kind of help design better? So I'm going to sort of show a few examples just to kind of indicate this, but I think it's important to kind of look a little bit at the history and sort of some of the kind of originators of this. And specifically, we owe a big debt to people like William White. Famously, he sort of produced his book, Social Life of Small Urban Spaces, where he was kind of arguably one of the first kind of urbanists or sociologists, and he also did sort of organizational analytics to kind of bring a sort of scientific method in there. And arguably he's kind of one of the, what you might call kind of big three kind of people that were involved in planning in New York. So we have sort of Robert Moses, very willful, sort of designer, sort of functionally kind of orientated, but not necessarily kind of testing those theories. Jane Jacobs famously kind of humanistic. How do we sort of create societies and cultures within cities? But I think William White is interestingly sort of right in the middle of that. And trying to really ask, well, how do we understand cities even in the first place? How do we kind of bring in an experimental kind of scientific approach into understanding not just the functional parts of cities, transportation, population scale, etc., but how do we understand what makes spaces good? So his kind of seminal work is a book, and also it's a 1-hour video on the social life of urban spaces. And what this kind of demonstrates is a kind of first of its kind of approach to kind of really get into the data of how cities are used to kind of measure them. And what he was able to do sort of over 15 years collecting data was to kind of really understand kind of from an urban point of view, what makes cities enjoyable, what makes social spaces kind of bustling, enjoyable spaces, as opposed to badly designed spaces. And we can see that, you know, having good social spaces in a city is a great way of kind of improving health, getting people outside to make the most out of them. And he kind of identified these key factors as a part of his research. You know, sitting locations, good access to the street, you know, quality sunlight, you know, food options, water, trees, triangulation. There's all these kind of interesting things that he was able to show. And what's kind of, while some of these things are kind of relatively obvious, his real kind of sort of power was in being able to kind of objectively show that, you know, this is actually what's going on, to sort of correlate that. And that was done with actually kind of using the technology of the time to sort of observe actually people's activities, which is something that hadn't been done even, you know, kind of with modernism being a kind of a willful kind of activity of kind of creating these new large concrete forms. But arguably William White was one of the first people to kind of really scientifically understand what's going on. So at the time, this was all done using relatively rudimentary technology. There were kind of basic cameras sort of set up, cine film, kind of physical film sort of set up over time, but a lot of it was done with individuals looking at cities, trying to understand what the behavior was, understanding where conversations were happening, etc., etc. But this is incredibly time-intensive work, and this is often why this isn't done in cities and we don't understand them as much as we could. As I say, this project took 15 years, but there's also a question of, if we have this level of human observation there, do we even affect, you know, how people behave if they're that sort of observed? That being said, I think what he was able to find was really interesting correlations of how people use public spaces and how the design of those spaces sort of heavily kind of influences where people go. So people that are kind of in larger social groups tend to be sort of in the front of a space, whereas people having smaller conversations tend to be in the back, kind of more constrained, more kind of private areas. But importantly, he was able to kind of find these results by kind of really applying data, and one of the first people to kind of visualize the data of the city. So in this sort of simple example where people sit along the edge of a public promenade, he was able to show, for example, people don't have an absolute sense of how close it is reasonable to be to someone. It's actually a lot more relativistic. So people are happy to be actually quite close to people that they don't know, as long as, you know, on average, there's a kind of a high density of people. So understanding these kind of fundamental rules of the city was something that he was able to kind of build, firstly by kind of just visualizing the data and understanding it, but then also by kind of cross-comparing all of these sort of different various public spaces in New York, where he did most of his research, and kind of understand the relative trade-offs between, you know, designers providing different amenities and how much real impact they have in terms of enjoyable, healthy, kind of, you know, public, enjoyable sort of humanist social spaces. So he was able to kind of find these. This is sort of one of the kind of gems of his research, of really demonstrating, for example, these kind of parks that were incredibly sort of successful because they had the right kind of seating, they had flowing water, they had beverages and drinks kind of freely available, they had different people to look at, and they had sort of nice shade and seclusion and vegetation, and being able to show that all of these things sort of generate real public spaces. And as a result, a lot of this work was then kind of folded into New York planning and global planning, so the sort of impact on our cities is quite immense. So I want to kind of look a little bit at sort of, if we take these methodologies and we kind of push them forward with kind of modern technology, and I'm really interested in how we can use this to kind of address sort of new problems that exist in our cities, and how we can kind of make the city more livable and more productive, especially for kind of older population, people that need to get out and walk more, which is sort of, walking has been shown to be a very good, healthy activity, and increases a lot of has a lot of very good benefits. So we've been doing a project with Tampines Town Council to have a look at how we can use AI to kind of really understand how these kind of precincts work and how we can kind of intervene with them. I'm very indebted to the team I work with, specifically Belinda UN, who's the PI of this project, but we've also been collaborating with medical staff from Tangi General Hospital and other sort of precinct leaders for Tampines Town Council and Tampines in general, that are really looking at how we can make these areas kind of healthier. So our kind of initial background is, a technology that's relatively ubiquitous, especially in developed countries, of, CCTV, various kind of security surveillance. But what we're interested in asking a question is, can the use of this be pushed less towards the individuals to surveilling them, but more towards the space itself? So asking questions about, can we use this technology to really understand how the space works, and maybe sort of critically kind of appraise whether it works well or not, and how maybe the design intrinsically kind of builds in better or worse kind of behaviors within people. So a specific one that we found when we did a whole host of surveys with kind of elderly users of specifically Tampines, is that we found that their propensity to walk around was kind of very different based on kind of how they perceived various kind of stresses in their environment. And one sort of on the high part of that list was for elderly walkers specifically, was this issue of personal mobility devices, so electric scooters, as well as bicycles, which are able to co-share a lot of the pavements and things in Singapore. And this is kind of this fear is not unjustified. It's kind of brought out by even kind of incident data that since electric scooters have been going up, so have the accidents, and the elderly people are really concerned about this. And this is sort of one of a number of primary reasons maybe they're less inclined to walk around for pleasure, but also for health. So we've been having a look at trying to understand this phenomenon over a number of places, but I'm just going to highlight just a small junction as a way of kind of understanding what's going on. But what we're interested in here is sort of, how do the people and the bicycles kind of interact? How can we maybe try and reduce the stress here? But how can we even kind of measure this? So we've been kind of investigating kind of new methodologies to really kind of come up with ways of kind of measuring kind of interaction between maybe less favorable types of vehicles. So here we can look at all of the people, where they go, and you can see this is already kind of far and away kind of longer durations that William White was able to kind of record using the cameras at the time for sort of upwards of about 3 or 4 hours. And we have sort of footage of weeks. We're able to see the sort of trends of people commuting to back from home at sort of 6 o'clock. But we're also sort of able to sort of capture kind of where they are in space in this instance. And then we can do the same for different road users. We can look at things like motorcycles and specifically bicycles, and we can see kind of where their kind of relative road uses are. And importantly, what we can do is we can kind of cross compare these and look at kind of where actually these clashes really exist, where the problem arises. And if we look at things like where people wait for the traffic light, so obviously inherently this is going to lead to kind of collisions as they cross. We can look at kind of where people are waiting. And if you look on the right hand side, there's actually a bike lane. So there's already kind of urban planning that's trying to segregate people, but you can see even in this picture that there's a pedestrian where the cycle lane is on that right hand side. So what's interesting about this is that, kind of using this data, we can get a much larger picture over many, many hours of sort of who's using various areas of space and when are various kind of users in sort of various zones that maybe we wouldn't expect them to be in, or that we'd be worried about clashing, and why. And what's sort of interesting, if you can see here, that there's someone sort of just pressing the button to cross, but there's also an area of shade there. So we already were able to identify, actually even in this picture, that actually a lot of the pedestrians end up right where the cycle lane is, because they're pushing a button. That's a necessary thing to cross the road, but also they're there because of the shade. If we have a look at this video, you can see there's a small patch of shade here. So we already have sort of, through these kind of observations, able to sort of say, well, actually maybe shade is important to kind of spread out users at various times, to give them more space between each other, but also maybe we need a separate button, you know, kind of moved away a little bit, for pedestrians, and a separate button for cyclists, so that we can kind of separate those users and not have them interact so much. So we're very keen to kind of explore these kind of data-driven approaches to really getting a grip of the sort of mass use of the city, hopefully leading towards a number of interventions that we're going to be doing later this year, where we're able to kind of really look at the trade-offs between different urban spaces. You know, as we try different configurations, we can look at the opportunity, the benefits, and the cost of doing these, and whether they're worth it. Typically doing urban interventions costs a lot of money, you know, changing things on streets. There's a lot of streets and urban furniture to look at. So we're able to kind of look at, you know, is it cheaper and more advantageous just to put some road markings or to have some blocks? And we think that there's not enough kind of objective data, and this is what our research lab is looking at providing. Going beyond the sort of small social, kind of the smaller kind of urban spaces, there's a really interesting question where we've been collaborating again with Changi Hospital to really understand actually what that means in terms of people's actual experience of the city and of urban space. So more and more what we're finding is that people, you know, are living in kind of heavy urban areas, and there's a question about how do we make sure that they keep connected with nature. Seeing greenery is shown as a good way of kind of reducing blood pressure, reducing stress, you know, having more enjoyable, pleasant walks, as well as, you know, having a level of sociability. It's also seen in the literature that kind of seeing people, especially elderly people, that are able to kind of interact even kind of with social scenes, not even if they're a participant, has beneficial effects to their health, sort of participating in society. So we've been interested again in sort of how do we bring data into seeing this, and one of the ways that we're actively going about this is developing an approach using these little live logging cameras, which are very easy things that people can just clip onto their clothing, and what this does is it records an image every minute, and effectively it creates like a record of all the time that they're wearing them. So we've been working with a few participants to kind of work with this sort of fascinating data, but we've been using machine learning to actually kind of categorize what they see, because obviously if we're making one picture a minute, we're making a lot more data than you can really as a human kind of process. So applying machine learning, we can kind of build this kind of level of intelligence on top, where we can kind of, I see from a high level what actually these people's activities are. So you can see on the top level, here's someone walking around a park. These are some samples of the pictures over their trip. And we can see that this has identified that this person is looking at lots of vegetation, a fair bit of sky. And you can actually even see the fact that they're sort of going from quite sort of roads, buildings in grey to this green space and then back to buildings. Whereas someone who's walking around inside maybe can see more people, as we can see in red, but also they just see a lot more roads and sidewalks. So maybe it's less interesting, or less kind of less of a nature walk, but maybe it's better sort of socially. So what we're able to do with this is, again, capture kind of much larger amounts of data than would have been sort of possible before. So people have been wearing these for like a whole week, and we can build up a narrative of what their routes are, what their activities are. And this is a sort of unique data source that we can kind of bring to bear both in architectural and design planning, but also even for clinical work to kind of understand individuals, what their activities are. Here we can see someone walks around in a park during the morning, and then in the afternoon often kind of has a much more urban kind of experience. And we can also do this in terms of comparative analysis of sort of looking at, you know, are there different factors that affect people's health, and is this related to how they walk around and what kind of walks what they're taking. So I'm going to go over very quickly, but there's also an opportunity to use this sort of data to understand cities kind of more broadly. And we're very interested in kind of broadening the conversation to look at things like sort of sentiment in urban design, which we can capture using kind of social media, things like Twitter, etc., and sort of what kind of activities do people do? How do we sort of bring in metrics to sort of understand the city that move away from sort of the typical land use and transportation type questions, and look at more of these kind of interesting interactions. For example, tourism, especially kind of pre-COVID, led to a lot of kind of issues of how people use their cities as locals, but also as tourists. How do we sort of understand the movement of this? And even going as far as kind of asking questions in an aviation sense of, we have a very big aviation kind of network, people are flying again. And there's a question about how do we sustain this? How do we keep aviation healthy? How do we allow people to travel, but also not, you know, affect the residents around the airport? So we've been doing work, again, looking at machine learning and kind of understanding actually what are the land uses around airports, you know, what's the possibility of these airports kind of affecting people's health or kind of their ability to expand, and should we be thinking about where airports should be moved in the future to make them healthier in relation to their city, because they're a big sort of stressor, but also they can be a big kind of benefit to aviation. So I'm going to finish with a sort of a look more at the design side and the opportunities within kind of AI and applying AI to design, and how we might be able to think about that, especially in terms of being able to coax it into something maybe more healthier. So we had the opportunity to work on something called Virtual Singapore, which is a digital twin. So it's a method of understanding the city. And typically a lot of these digital twins we've developed similar in the bottom right, have these metrics that look at what are called 15-minute cities. How easy is it to move around a city? What kind of amenities are available? It's been shown that, you know, having a residential area where from your house you're able to access most amenities and public transport into the city in 15 minutes creates kind of very healthy, well cities. However, there's some interesting questions about how we sort of design these. So once we can measure them, this is one thing, but then how do we actually sort of design cities to do that is another question. But for this project, one of the things that we were interested in doing is asking how can we actually get the AI to look at designing the city itself. So we were developing a kind of a data set, which is, you know, the whole kind of urban configuration, and at a base level, trying to get it to sort of understand what is the logic for how we put a plot of land together. So how do we kind of allow the computer to be able to kind of basically become a kind of an urban planner? And urban planners typically understand, develop what the plot is going to be, what the floor, what the road network is going to be, etc. And then it's actually the developer that kind of puts the design in, or the architect working for the council. And there's an interesting question about how can we kind of work with AI to kind of really understand what the patterns are of this. So we've done work with AI in terms of trying to get it to kind of understand this, to kind of automatically kind of generate this, and specifically understand this in understanding the context around it. So if we have a city, in reality, it's very hard to design without understanding the context. So whereas previously we were looking at solutions where, you know, we start off with an input image, which is a blank city, and asking it to fill it in, which it inherently finds some difficulties. We can see sort of quite unresolved designs. Whereas if you already give it an urban context, for example, the actual predicted urban plans become a lot more kind of rational. And we can even do this with urban greening, where we can investigate the ability of algorithms to kind of understand that. So what I think these are kind of very useful kind of urban tools. There's opportunities to kind of automate and to kind of look into the future of what different configurations will be. But I think there's a real opportunity here to ask some questions about actually what kind of data we should be putting into these AI systems. So I have a sort of a somewhat trivial kind of example, but I think it's an important kind of way of thinking about how we're training AI and what its kind of application is, especially in these more kind of creative venues where there is not necessarily one right answer. Instead, we're trying to find these answers that are kind of more creative, more interesting, more human. So as a sort of a way of thinking about this, one way is maybe these kind of manhole covers, which is in Japan a big area of interest. There's lots of different designs for all these various towns and cities have their own individual idea. And if we put all of them, there's actually a huge database of these, all into a machine learning algorithm, what we tend to find, you can sort of see, is that we end up with some designs that are quite sort of normal. They're quite a little bit boring, if I can offer that. They're all kind of the same gray color. They have a sort of a texture. So even though this isn't a sort of highly trained algorithm, it's still quite average. But if we then sort of decide to have some criticality and we say, okay, actually, we're really interested in the kind of manhole covers that have some interesting colors. They're not just gray. If we look at clustering the kind of average colors, we work out what the palettes are, and we just pick the ones that are kind of more enjoyable, you know, kind of more fun, they sort of give us joy. Then what happens if we put those into an AI? And so the AI already has a sort of a critique deciding what it should learn from. And what we get is something that's a lot more kind of interesting, right? And a lot more kind of humanistic in the kind of designs that we might get out. And I think this is kind of important, something I've sort of written on a bit, of our kind of desire, or our need rather, to really be careful with the kind of data that we put in. So I think with this urban activity, for example, I think we have to be critical about how do we decide what's kind of good, you know, how can we make these systems kind of learn from good neighborhoods that are kind of effective and so on, rather than just training them on the whole city, which is not always sort of the most functional thing. And then just sort of one final thing to consider. I also think the more and more we kind of tend to use data and AI as a design tool, especially kind of at the urban scale, where there's a lot of data that we have to aggregate to really understand people's activities. I think we need to sort of talk about this a lot more, is sort of how do we kind of build up data sets that can do societal good, but are sort of shepherded and controlled carefully. I think there's some interesting work from people like Alex Benton, who's kind of working on this, and others asking how kind of as academics and also from a commercial side, we can kind of work on this data. And I think actually the medical industry is a great place to sort of learn more from that. So that's my kind of thoughts on the intersection between AI and architecture, and specifically how we can kind of move it towards a more sort of healthy and humanist approach. So thank you.
Thank you very much, Sam. Very, very interesting how you do the intersections of AI and data analytics, especially in building and planning. There is a question from the floor. The question is this: will the cost of healthcare expect to be lower with more involvement of AI?
Ooh, good question. I think with urban design, I guess what we're often trying to do is reduce mistakes, right? Get it right the first time. And I think, you know, often with cities, it's incredibly difficult, because often you build something and then 10 years later you work out whether it works or not. The kind of, you know, the iteration cycle in cities is relatively slow. And I think that's where one of the big powers of using machine learned data is really powerful, because you don't have to just learn from, you know, a single city that you're operating in, but you can aggregate data from, you know, global data sets and things like that. So I think there's an opportunity there, hopefully, to make kind of more informed decisions. And I think that's sort of the key part of that, of, you know, architecture is always, things at an urban scale are always quite expensive. But if we sort of manage to design them correctly the first time, informed by, you know, larger kind of sets of information, then our sort of possibility of getting it wrong is kind of is less, right? So I think there's an opportunity there to kind of reduce costs. Yeah.
Okay, great to hear that, because I think cost is always important, especially going into the use of technologies. Now, you mentioned quite a fair bit about data, and as we know, this phrase that garbage in, garbage out, right? Because basically you must have good data. So how do you handle fake data? How do you handle poor data in your field of work?
Yeah, I mean, I guess we're somewhat lucky in the sense that, you know, it's hard to fabricate a city. So we use aerial imagery, we use, you know, kind of various mapping, etc., of the city as our kind of base data, and we also provide our own CCTV, etc. So we're kind of using quite raw data sets rather than, you know, kind of artificial ones. But we've used things like social media data, which is often full of, yeah, kind of artificial messages and so on, and invariably there's cleaning required there. But I definitely agree with that principle of the garbage, and that's sort of almost my point, is that what we're often doing at the moment in kind of architecture, specifically in relation to AI, and I think this is happening across the board in terms of kind of creative use of AI, is we're taking in as much information as possible. I think you might have seen things like DALI, which was recently kind of demonstrated, which is an incredible ability to kind of create images. But inherently that has kind of biases based on everything it's seen, right, before. And what's interesting is that I think we need a certain level of kind of criticality about what that is. And I think especially in that context about what's healthy, you know, and that's why I think there's a real kind of need within, especially when we're sort of training sort of AI for design type activities, of criticality of saying, okay, just because it can create something automatically, let's make sure that that thing is good. Because, you know, a lot of people could design you something. You know, a fair number of 4-year-old children will draw you a house, but you wouldn't actually want to live in that house more often than not. You know, it takes a while to kind of build up your criticality of what are good designs and what are bad designs. And I think that's a thing that we need to develop more of, that while some data sets are, you know, some data points are kind of useful in terms of understanding a typology or kind of training a model, maybe some are more useful because they're actually good designs. They kind of provide, you know, humanist or healthy sort of spaces for us, yeah, or more sustainable designs as well. Yeah.
All right, thanks, Sam. Times is up, just nice, perfect timing. So let me move on to the next speaker.